All right, so now we're going to continue section 8.3 by looking at example 3. So in our previous video, we just learned about this theorem to help us determine the divergence of a series called the divergence test. So example 3 says, give a formal proof of the series, or that the series, the sum from n equals 1 to infinity of n over n plus 1 from example 2 diverges. So we're told what the conclusion is here, and we worked it out in example 2. So this series we know converges, but we want to give a formal proof that it does. So we're going to go through this example so you can see a model of how this is done. And then I'll summarize a few key takeaways that we want to make sure we always include when we're writing a formal proof. In mathematics, formal proofs are really important to convince someone else that what we're stating, so for example, divergence of a series, is in fact true. In mathematics, nothing is true unless it can have a formal proof. So in this section, we're learning also how to develop those formal proofs or formal rigorous arguments. All right, so let's go ahead and get started. So what we know about the series is that it diverges because these terms do not go to 0. So let's begin with that. So since, I'm going to back up and use a different pen here. So since the limit as n goes to infinity of n over n plus 1 is equal to, by L'Hopital's rule, the limit as n goes to infinity of 1 over 1, which is 1, and that does not equal 0. This means the series, let's go ahead and spell that right. The series that is the sum of n equals 1 to infinity of n over n plus 1 diverges by the divergence test. Done. Some people like to conclude their proofs with a little square like this or a little box like that, but we can just leave it here. Okay, so that is a formal proof that this series diverges. So what were some important things that we included in this proof? Well, first of all, in a formal proof, we always want complete sentences. We don't just want to show work like, oh, here's the limit and here's the result. A formal proof means that we're writing up the results, meaning we're using complete sentences. We're also using correct notation. Everything that we write on our paper needs to be correct and in the appropriate notation. So we see this in our work when we're writing out this limit here. So using the limit here, so not dropping the limit in a certain stage. We also need to clearly write what theorems or facts we are using. So, and where we use them. So that happens here when we say that we're using L'Hopital's rule. And that happens here when we're saying that we made this conclusion using the divergence test. All right, so these things are essential and necessary when you create a formal proof. We're going to see some more examples of this.